I am Dr.G.Vijaya Gowri, Professor at the Department of EEE, KSRCT College of Technology. Here I would like to discuss about the energy storage for electric vehicles. The electric vehicles run using electricity. In order to feed the vehicles with electricity, we require a device. A pure electric vehicle can have any of the energy storage devices such as battery, combination of ultra capacitor and battery, combination of ultra flywheel and battery, combination of fuel cell and a battery. So these energy storing devices provides the required input to the vehicle. Batteries are the sole energy source providing energy to the vehicles. Batteries alone cannot provide, so research is going on in the use of ultra capacitor, ultra flywheel, and fuel cells to increase the performance of the electric vehicles and thereby the electric vehicle market in India and around the world. Batteries, we have two types: primary batteries and secondary batteries. Primary batteries are the batteries that cannot be recharged once all the charge in the battery is depleted. They are made of electrochemical cells whose electrochemical reaction cannot be reversed. Whereas secondary batteries are the batteries where the chemical reaction can be reversed by applying some voltage in the reverse direction. They are also called as rechargeable batteries. So these secondary batteries are used in electric vehicles. The batteries are rechargeable. The rechargeable batteries are categorized as lithium ion batteries, nickel cadmium batteries, nickel metal hydride batteries, lead acid batteries. These are the common rechargeable batteries used or preferred for electric vehicles based on their advantages and the disadvantages. The important terms or the parameters related to the batteries are battery state of charge and depth of discharge. Battery state of charge is the fraction of the total battery capacity that is used over the total available energy from the battery. The depth of discharge, it is the fraction of power that can be withdrawn from the battery. We cannot use the maximum full energy from the battery. So the amount of power that can be withdrawn from the battery is the depth of discharge. Seeing the charging time of the battery, we can calculate the charging time using the battery capacity and the charging current of the battery. Supposing that the battery capacity is 120 ampere hour, the charging current is usually 10% of the rating of the battery. We have considered 120 Ah, so the charging current will be approximately 12 amperes, as we have considered 10% of the rating of the battery. But due to some losses, we can consider the current to be between 12 to 14 amps. Now let's consider 30 amps for charging purpose. So the charging time for 120 Ah battery will be approximately 9.23 hours. But practically 40% of losses occurs while charging a battery. When we consider 40% of 120 ampere hour of the battery rating capacity, include we get 48. So the total capacity is considered as 120 plus 48, 168 ampere hour. Now the charging time is calculated to be 168 divided by 13, which is around 13 hours. So 120 Ah rating battery takes 13 hours to charge fully in case the charging current is 13 amperes. Usually a battery takes more time to charge and it will discharge in less amount of time.